So standard position angle is defined by the point -2, -9. So I'm just going to draw that in. And since the position is known, again, we have to consider θ1 and θ2, but we know that the answer is just going to be one angle. The one position is known. So I'm going to use Pythagoras to find the third side here. So square root 85 represents my radius. I want to find the exact value. Okay, so I've been given two sides of the right triangle, so I need to keep this triangle in exact values. So I need to write my cos. My cos theta is -2 over root 85. Sine theta is going to be -9. Again, that negative is really important because it locates that position. And my tan looks like it's positive slope. So negative divided by negative gives me my positive 4.5 slope. And then solving for the angle, I'm going to use any one of these to find the angle. So I'm going to use, in this case, arc sine. So I know that if I'm going to use an arc sine, the input is not my angle, but the input has to be the ratio, and the output will be my angle theta. Okay, I never sine a ratio. So I'm going to do, at this point now, I have to rely on my calculator, so I can no longer keep exact values. So I'm going to second sine this value, or inverse sine, and I'm going to end up with -77.47 degrees. Okay, now this is my θ1, and if I look at my diagram, θ1 is in the wrong position. So I'm just going to do this different color. So θ1, -77.47 degrees. It's in the wrong spot. It's over here. Okay, that's the position point that locates my θ1, -77.47 degrees. I'm in the wrong quadrant, so I need to use symmetry to find the correct positional angle. And that, in this case, it happens to be θ2. And so I'm going to do, I can use a formula, or I can just add the reference angle. I'm going to use a formula. I'm going to 180 minus -77.47. So I get positive 257.47 degrees. Okay, so the formula involves symmetry. There's symmetry in the diagram that you can use to find that other angle. Okay, so that's important that we, again, the position is important. We have to consider two angles, two positions, and since the position is known, we have to decide which of the two, θ1 or θ2, is in the right position.